You can find the sine of 2 alpha and the cosine of 2 alpha given that the sine of alpha, half that angle, is 4/5, and that alpha is acute. I recommend start with sketching a triangle. So I'm going to begin with just a random right triangle, throw alpha in a corner, not super duper important. The orientation of the angle, I'm not going to worry about positives and negatives right now. Sine of alpha is 4/5, so sine, opposite over hypotenuse, 4/5. I recognize this immediately as a 3, 4, 5 triangle. Now I'm going to double check that I've got the sine, that I've got alpha in the right orientation. So sine of alpha is positive. Either both these are positive numbers or both of them are negative. Given that I'm told that alpha is acute, this suggests to me that I'm sitting in quadrant 1 on the coordinate plane. So I've got this right. 3 and 4 both need to be positive. Next step. Let's apply the double angle formula as such. This is straight from the sine double angle formula. And my next step is I'm going to substitute in what the sine of u is and what the cosine of u is. But after I knock the camera over. All right, so sine of 2u. I'm using u's here because these are straight off my paper. On my example, these are alphas. Okay. Sine of 2 alpha is 2 times the sine alpha. Sine of alpha we were given 4/5. Cosine of alpha, adjacent hypotenuse, 3/5. Multiply this out and simplify. Sine of 2 alpha is 24/25. Now let's find the cosine of 2 alpha. Go consult one of the cosine double angle formulas. I'll stick with this one. And you'll just recall that for our double angle formulas, that there are actually several options in cosine land. Okay, so my cosine option that I picked here, good. Let's fill in numbers. Cosine squared of alpha. Sine squared of alpha. Now it's time to simplify. That is the same as 9/25. And this is 16/25. The fact that the cosine here of 2 alpha is negative suggests to me that 2 alpha is sitting in either the second or third quadrant. That's how to do example 1 out of lesson 6.4.